Hi all, this is me Amina Khan and I welcome you to this bootcamp of data science. It contains everything that you need to know in order to step into the field. There is no doubt that data science is the most revolutionary technology of the era. It's all about driving useful insights from data in order to solve real-world complex problems. Now, without much ado, let's take a look at the agenda for today. First of all, we'll talk a little bit about data science and the what's and why surrounding it, and then we'll talk about who is the data scientist and the various responsibilities and roles. And next, we are going to solve a problem using data science, which is actually the most critical part of this session. Finally, we are going to talk about a few data science tools and then move on to our demo. So let's get straight into the session.
So why data science? Why do we need this technology? Traditionally, data we had was mostly structured and kind of small in size, which could be analyzed using simple BI tools. Unlike data in the traditional systems, which was mostly structured, today most of the data we have is unstructured or semi-structured. So over the past few years, companies have been storing their data. And this has been done by each and every company that exists today. So because of this, it has suddenly led to this data explosion sort of a situation. And data has become the most abundant thing that we have today. But what can we do with this data? Let's understand this using an example. Say you have a company which makes mobile phones. You released your first product and it became a massive hit. But every technology has a shelf life, right? So now it's time to come up with something new. But you don't know what you should innovate that is new and also meets the expectations of the users who are eagerly waiting for your new release. So somebody in your company comes up with this idea of creating this user-generated feedback system. So basically, you ask a bunch of people what they want from their new mobile phones, and then you pick things which you feel that you can deliver, and then you plan your next release. But that's like a lot of people and a lot of data. So here comes data science. You apply various data mining techniques like sentiment analysis and get the desired results. It's not only this, you can also make like better decisions with this because you are creating an efficient system which will ultimately reduce your cost, make your decision making process faster, and with that you can actually give your customers what they want. Not just that, it will help you in your risk detection also. With today's world and digital money, data science can help you prevent the fraudulent transactions using machine learning algorithms, and it can help you prevent great monetary losses which can be really harmful to your company. So requirements like these has led to data science as a subject today, and hence this module. But what is data science? Now we know why do we need data science, but what does data science actually mean? Now the term data science has emerged very recently with the evolution of mathematical statistics and data analytics. The journey has been amazing and there has been a lot that has been accomplished in the past few years. In the next few years, we will almost be able to predict the future as claimed by researchers from Massachusetts Institute of Technology. They have already reached a milestone in predicting the future with their awesome research. They can now even predict what will happen in the next scene of movies with their machine. How? Well, it might be a little complex for you to understand, but don't worry. By the end of this module, you shall have an answer to that as well. Now coming back, we were talking about data science. It is also known as this data-driven science, which makes use of scientific methods, processes, and systems to extract knowledge or insights from data in various forms, either unstructured or structured. Now here is the process of data science as you can see on your screens. It starts with some analysis, then putting data in structure, then creating an algorithm or a process. Then there is some coding happening, and finally you get a visual or an insight on the data that you've sent in. So if you're asking for insight from a case, data science will give you an answer from three perspectives: statistics, code, and business. So the use of the term data science is increasingly common. But what is the basic difference between BI and data science? How are decisions and predictions made in data science? These are some of the questions which a lot of people have. So we can get a better insight about these by knowing what is the difference between a business analyst and a data scientist, and how is this different from what statisticians have been doing for years. So the answer lies in the difference between explaining and predicting. As you can see from the image in front of you, a data analyst usually explains what is going on by processing history of the data. On the other hand, a data scientist not only does the exploratory analysis to discover insights from it, but also uses various advanced machine learning algorithms to identify the occurrence of a particular event in the future. A data science will look at data from certain angles, sometimes angles that are not even known from earlier. So basically what he does is he extracts meaningful insights from complex and large histories from all around us and gets an in-depth knowledge so he can predict an event before happening in the future. So the next logical question obviously is, who is a data scientist? Now, a person who brainstorms all this is a data scientist. A data scientist is a master of all trades, as you can see from this image in front of you. He should be proficient in math, he should be acing the business field, and also should have great computer science skills. Scared? Don't be. Though you need to be good in all these fields, but even if you aren't, you're really not alone. There's no such thing as a complete data scientist. If we talk about working in a corporate environment, the work is distributed amongst teams, wherein each team has their own expertise. But the thing is, you should be proficient in at least one of these fields, if not all three. Also, even if these skills are new to you, it may take time, but these skills can be developed. And believe me, it would be worth the time you will be investing. Now, what does a data scientist do? What are his roles and responsibilities? So, a data scientist is responsible for a couple of things, namely optimizing and building classifiers using machine learning, data mining, processing and cleansing data, extending data, and building prediction models. You will know more about all these roles when I talk about how to solve a problem in data science. So how do you solve a problem in data science? Before that, let's know about the life cycle of solving a problem in data science. It starts with discovery, then data preparation, model planning, building a model, operationalizing, and then finally communicating the results. So your phase 1 is discovery. So before you begin the project, it is important to understand the various specifications, requirements, priorities, and the required budget. You must possess the ability to ask the right questions, and here you assess if you have the required resources present in terms of people, technology, time, or data, which you need to support the project. In this phase, you will also need to frame the business problem and formulate the initial hypotheses to test. Next, you have data preparation, and possibly the most time-taking of all of these steps. In this phase, you'll require analytical sandbox, in which you can perform analytics for the entire duration of the project. You'll need to explore, pre-process, and condition your data, and clean a lot of data. Further, you will have to perform the ETLT, which is extract, transform, load, and transform to get data into the sandbox. And then you can use R for data cleaning, transformation, and visualization. This will help you to spot the outliers and establish a relationship between variables. Once you have cleaned and prepared your data, it's time to do exploratory analytics on it. Next, you plan your model. Here you will determine the methods and techniques to draw relationships between variables. These relationships will set the base for algorithms which you will implement in the next phase. You will apply exploratory data analytics using various statistical formulas and visualization tools. A few of those tools are the SQL Analysis Services, or the SAS, you have R, and you have the SAS Access. Although many tools are present in the market, but R is the most commonly used tool. Now that you have gotten the insights into the nature of your data and have decided the algorithms to be used, in the next stage you will be applying the algorithm to build up a model. Next, model building. In this phase, you will develop datasets for training and testing purposes. You will consider whether your existing tools will suffice for running the models, or it will need a more robust environment, like suppose fast and parallel processing. You will analyze various learning techniques like classification, association, and clustering to build the model. And you can achieve the model through a bunch of tools, which are your SAS Enterprise Miner, your WEKA, MATLAB, and much more. Your step 5 and the penultimate step is to put it into operation. In this phase, you deliver final reports, briefings, codes, and technical documents. In addition, sometimes a pilot project is also implemented in real-time production environment. This will provide you a clear picture of the performance and other related constraints on a small scale before you completely deploy the model. And finally, you communicate. So basically, you communicate your results to people who you report to. Now, it is important to evaluate if you have been able to achieve your goal that you had planned in the first phase or not. So in the last phase, you identify all the key findings, communicate to the stakeholders, and determine if the results of the projects are a success or a failure based on the criterion you have developed in phase 1. Now, remember the algorithms we talked about earlier? Here is how you choose them. So now let's discuss how should one approach a problem and solve it with data science. Now, problems in data science are solved using the algorithms that we spoke about earlier. But the biggest thing to judge is which algorithm to use and when to use it. Basically, there are 5 kinds of problems or questions which you might face in data science. So let's address each of these questions and the associated algorithms one by one. Is it A or is it B? With this question, we are referring to problems which have a categorical answer, as in problems which have a fixed solution. The answer could be either yes or no, 1 or 0, or A or B. Maybe you're interested or uninterested. So for example, what will you have, tea or coffee? Now here you cannot say you want a Diet Coke, since the question only offers tea or coffee. Hence you may answer in one of these two. When we have only 2 types of answers, it is called a class 2 classification. And in this, you use a classification algorithm. Whenever you come across questions, the answer to which is categorical, in data science, you'll be solving these problems using classification algorithms. So the next problem is it weird? Now, questions like these deal with patterns and can be solved using anomaly detection algorithms. For example, try associating the problem, is it weird, to a situation where everybody in school is in uniform. There's just one person who's in casual clothing. Wherever there is a break in pattern, the algorithm flags that particular event for us to review. A real-world application of this algorithm has been implemented by credit card companies, wherein any unusual transaction by a user is flagged for review. Hence, they implement security and reduce human efforts on surveillance. Now, let's look at the next problem in data science. How much or how many? So for those of you who do not like math, be relieved because regression algorithms are here. So whenever there is a problem which may ask for figures or numerical values, we solve it using regression algorithms. For example, what will be the temperature for tomorrow? Since we expect a numeric value in the response to this problem, we will solve it using regression algorithms. Moving on, let's discuss the next algorithm. How is this organized? Say you have some data. How will you make sense out of it? Hence the question, how is it organized? Well, you can solve it using clustering algorithms. So how do these solve these problems? Clustering algorithms group the data in terms of characteristics which are common. Now, for example, if you have a bunch of gems and you organize them using colors, you basically have got yourself a bunch of clusters. So similarly, be it any data, clustering algorithms try to apprehend what is common between them and hence cluster them together. And the next and final kind of problem in this tutorial that you may encounter is, what should I do next? So whenever you encounter a problem wherein your computer has to make a decision based on the training that you have given to it, it involves reinforcement algorithms. We shall talk about a topic pretty similar to it a little later in this module. So back to reinforcement algorithms. For example, you can take the temperature control in your office or your room, like your AC, which has to decide on its own if it should lower the temperature of the room or increase it. So how does this algorithm work? This algorithm is based on human psychology. We like being appreciated, right? Computers do too. Now, rather than teaching your computer what to do, you let it decide what to do, and at the end of that action, you give it either a positive or a negative feedback. Kind of like how you rate your Uber drivers. You don't really have any control over your ride, but after the ride, you can rate them from 1 to 5 stars depending on how well your ride went. So let's apply this understanding and imagine you are training the temperature control system or the AC. So whenever the number of people in the room increase, there has to be an action taken by the system. Either lower the temperature or increase it. Since our system does not understand anything, it just takes a random decision. You have to tell it by giving a feedback whether the decision is right or not. And slowly it gets trained into taking the right decisions in the right situations. So this is all about reinforcement algorithm. Now the algorithms that we learned involve a common learning practice, right? So we are making a machine learn. So this is called machine learning. It's a type of artificial intelligence that makes computers capable of learning on their own, that is, without explicitly being programmed. With machine learning, machines can update their own code whenever they come across a new situation. Now, all this learning can be divided further into categories. Let's take the example of a child. Now, in the initial stages, you have to teach a child a concept, tell them what is right to what is wrong, and teach them what to do. Something like this is called supervised learning. This is where you tell your machine what to do. So we have categories of this algorithm, right? We can all take the example of a teacher teaching a child. So the first type is supervised learning. This is where you tell the child what they have to do. This is used in cases where we have a lot of information. Suppose a medical directory. We know the blood type of a person, their BMI, their weight, their height. We have a lot of information to deal with. So this is where supervised learning comes into picture. You have information and you're going to act upon it. Next, you have unsupervised learning. This is where the teacher lets the child decide for themselves what they have to do. It's kind of like running a store. You do not know what your customer likes, what color they like, what fashion they are into. You do not have any prior information. You're just going to see what your customer is going to buy from you. Next, we have reinforcement learning. This is a feedback-based system. It's like telling the child, if you do something right, you're going to be rewarded straight away. And if you do something wrong, you're going to be punished. If you remember from earlier, this is kind of like the reinforcement algorithm that I had spoken about before. This is how you train your machine based on feedbacks. So these are the various categories of algorithms on which you train your machine, right? So let's talk about some data science tools next. Now there are a bunch of data science tools that we are going to talk about, starting off with what we basically analyze on, that is our data. So you need a lot of data which needs to be analyzed, and this data is fed to your algorithms or analytical tools, and you get this data from various researches conducted on datasets. Next, you have your R Studio. Now R is an open source programming language and software environment for statistical computing and graphics. It is very simple and easy to learn. And R is an example of a free library and open source software, which basically means one can freely distribute copies of the software, read its source code, modify it, etc. Now the R Studio was sufficient for analysis until our datasets became really huge and also unstructured at the same time. Now this type of data was called big data. Now, it is a collection of data sets so large and complex that it became difficult to process using on-hand database management tools or traditional data processing applications. Now, to tame this kind of data, we had to come up with a tool because no traditional software could handle this kind of data. Hence, we came up with Hadoop. Now, Hadoop is a framework which helps us store and process really large data sets. So, it basically stores them in parallel and in a distribution fashion. So let me just give you a little brief about the process here. The storage part of Hadoop is handled by Hadoop Distributed File Systems, which provides a high availability across a distributed ecosystem. The way it functions is basically like this. It breaks the incoming information into chunks and distributes them into different nodes in a cluster, allowing distributed storage, hence more storage. Now MapReduce is the heart of Hadoop processing. The algorithms do two very important tasks. As the name suggests, map and reduce. The mappers break the task into smaller tasks which are processed parallelly. Once all the mappers do their share of work, they aggregate their results, and these results are reduced to simpler value by reduce process. If we use Hadoop as our storage in data science, it becomes very difficult to process the input with just RStudio. Due to its inability to perform well in distributed environment, we have Spark R. Now this is also an R package that provides a lightweight way of using Apache Spark with R. So why will you use it over the traditional R application? Because it provides a distributed data frame implementation that supports operations like selection, filtering, aggregation, etc. but on really large data sets. Now that we are done with all the technical talking, let's move on to our demo. So this is our RStudio and this is where we shall be coding. This is where you write the code, it is your script, here is your console. This is your environment where you can see your objects, and here is where you will be viewing your plots. So let's go and see our dataset. So this is our dataset. It's an e-commerce retail stores dataset, and it's got its invoice number and the description of the product, quantities, dates, and country. Now, typically e-commerce datasets are proprietary and consequently really hard to find amongst publicly available data. However, there are certain sources which have made the dataset containing actual transactions from the years 2010 and 11 available. The dataset is maintained on their site, where it can be found on the title Online Retail. This is a transnational dataset which contains all the transactions occurring between the December of 2010 to December of 2011 for a UK-based and registered non-store online retail. The company mainly sells unique all-occasion gifts, and many customers of the company are mostly wholesalers. Now, our aim here is to find the RFM, which are the three dimensions, which is recency, frequency, and monetary value for this particular online retail store. Now, how recently did a customer purchase? How often do they purchase? And how much do they usually spend? Now, the resulting segments can be ordered from most valuable, high recency, frequency, and value, to least valuable, which basically means lowest recency, frequency, and value. Identifying the most valuable RFM segments can capitalize on the chance relationships in the data used for this analysis. So let's go back to our RStudio. So I already have some data. I'm just going to copy it right here. I've installed all the packages. Once you install these packages, all you have to do is call them using your library. So I'm just going to call. Yeah, how you run code on RStudio is by pressing Control and Enter together, or you can just select it and use this Run button right here. So we have our data, which I've named hands-on. I've made a variable called hands-on, and I've allotted my dataset to it. Here we have installed the packages dplyr, which is basically a package for manipulating data. Then we have ggplot2, which is the package we'll be using for our plots. Then we have tidyr, which will be for cleaning our datasets. As the name suggests, it tidies. Then we have knitr, which is used for dynamic report generation. Then we have R Markdown, which is basically a lightweight markup language used in R. This is the location of where our data file is. So I'm guessing that's it. Now, first, we have to load our data and examine the dataset. So I'm creating a data frame called df_data, and we are just putting our variable, which is hands-on, and trying to get a glimpse of it. Here you see it. You can see the invoice number. Wait, let me just get in the highlighter, make it easy for you. Here you can see the invoice number, stock code, description, quantity, customer ID, and country. It gives you a glimpse of your data. Next, and very important, we are going to clean our data. So basically, we are going to delete all negative quantity and price. We also need to delete non-applicable customer IDs and recode our variables. So we're going to clean the data. The clean data looks something like this. And with that, we have dropped all the non-applicable values. Now we're going to recode our variables and convert character variables into factors. So the same thing. And then when we get a glimpse of our data, it looks something like this. Yeah? Now we're going to calculate the RFM. Now, to implement the RFM analysis, we need to further process the data. So first we have to find the most recent date for each ID and calculate the days to now, or like some other date which you want, to get the recency of the data. Next, we calculate the quantity of transactions by a single customer to get the frequency of data. And finally, we sum the amount of money a customer spent and divide it by the frequency to get the amount per transaction on an average, and that is monetary data. So let's go ahead and do that. Here you can see the customer ID and their RFM analysis, right? And the same thing, you see the customer ID and the recency, frequency, and monetary analysis. Here you see the highest RFM analytics right here of these customers. They're all arranged in a descending order right here. And here's the summary of it. Now we can get the histogram for all these three factors: recency, frequency, and Monterey. So all we have to do is use the function hist. This is the histogram for recency. Open this right here. Then this is the histogram for frequency. You can see right here. Open this as well. And this is our final monetary histogram. Let's just zoom on it. We see the frequency versus the amount spent right here. Now, because the data is really skewed, we can use a log scale to normalize it. Yeah. So we'll get a better graph of it. So let's use log on this Monterey. Now it looks less crowded and we're getting a perfect histogram for it. Next, let's do some clustering. For that, we get the data values right here. Same old, just the way we see all our results. You can see the recency, the frequency, and the Monterey in the first quadrant, and the third quadrant, the maximums, and the mean and the median. This is what clustering of data is. It's giving you a summary of your RFM. So we can put this in a dendrogram and plot that. Now, in order to visualize the result of an hierarchical clustering analysis, we use a dendrogram. And for that, we use the hclust function. Yeah. And then we plot it. Now, this is what a dendrogram looks like. It is because it's very, very clustered, and we are talking about like some 550,000 rows of data. But you can always break them down into a few thousands each time to make it less clustered. Next, we're going to use a cut tree function, which basically cuts a dendrogram into several groups. So this will make it easier for us.
Now we have cut it down to a group of 8 with again the recency, frequency, Monterey, and doesn't this look much better? With that, I have come to an end for today's session. I hope you have enjoyed listening to this video. If there is any question regarding to the topic, feel free to ask. Thank you so much. Have a great day.